Okay, hi everyone, and thanks for coming to our town hall. I'm Andy Campbell, the director of SEAS, Synchrotron Earth and Environmental Science. Today, we're going to kick things off with a presentation from Joanne Stubbs, the GSE card director, who will be updating us on the status of the APSU upgrade and its impact on SEAS facilities. Following that, Martin Kuntz from the Advanced Light Source will share information on the upcoming upgrade at the Advanced Light Source, ALSU. And for the remainder of our hour, Matt Newville of the University of Chicago will lead the presentation on the F.A.I.R data policy and practices for SEAS. We'll have time for Q&A after these presentations. Please put your questions in the chat or later in the Q&A period, perhaps by raising your hand. And a reminder to everyone, please mute yourself so that we can enjoy these presentations uninterrupted. Finally, before we get started, I want to remind everyone that SEAS will host another sort of informational town hall. Please sign up for that. If you will be attending AGU this year, it'll be taking place on Monday during the lunch break at AGU week. That'll be December 9th. Joanne, it's all yours.
Great, thank you very much. Let me go ahead and share my screen here. So I'm going to give an update on the APS upgrade, specifically as it pertains to SEAS beamlines, but I'll start with a little overview of the facility at a higher level. So I think probably, as many of you know, the APS shut down last year for a major upgrade, the result of which is a dramatic decrease in the horizontal size of the electron beam in the storage ring. This upgrade required complete replacement of the entire magnetic lattice within the storage ring. So all the magnets came out, the tunnel was completely empty, and then it filled back up again. That process started in April of last year. And in April of this year, just about a year later, they injected the first electrons into the brand new APSU storage ring. They spent the rest of April and May doing a little bit of troubleshooting and then initial storage ring commissioning, including demonstration of the world's first electron bunch swap out capabilities. And then in June began commissioning beamlines. The beamline commissioning process is a multi-phase or multi-step process that starts with something called ops commissioning, which is first beam and the verification of radiation safety shielding. Those things have to happen before anything else can take place. Once that's been verified, beamlines move on to technical commissioning, which is testing of the beamline components with beam. At this point, there are no external users involved. At the point that the beamline becomes ready to start doing some science experiments, it moves to a phase called scientific commissioning. That's early experiments they're really chosen and designed to help test and debug the beamline capabilities. And these experiments can and often do involve some external users. And finally, once we've determined that a beamline is really ready, we'll resume general user program. This is a process that's happening in a phased way across nearly 70 beamlines at the APS. This graphic is updated weekly on the APSU webpage. There's a link on the slide, and I think Emily's going to post that link in the chat as well. The 6 SEAS beamlines are highlighted in the red rectangles, and all of these have completed their shielding verification. 3 of them are currently in technical commissioning, and 3 have moved beyond technical commissioning into the scientific commissioning phase. And so I'm going to step through all of the SEAS beamlines at APS. I'll start at Sector 13, where I'm a beamline scientist and the director. For those who might not know us, GSE CARS operates Sector 13 for benefit of the Earth and Environmental Science community. We have 2 independent undulator beamlines in a canted geometry, and we have a bending magnet that we split into 2 separate subfans. So that means we can run 4 simultaneous experiments. We offer a large suite of techniques that enable our users to probe conditions ranging from those of the core through the mantle and crust out to the surface and biosphere and out through the atmosphere into space. And so what I'm going to do is talk you through now the status of those 4 beamlines. So on the bending magnet at 13 BMC, this beamline is in scientific commissioning. All of the major systems have been tested and are working well, although we're still debugging a few minor issues. And the first user experiments happened just a few weeks ago. We expect that beamline to return to general user operations in the first run of 2025. At 13 BMD, we are also in the scientific commissioning phase. Most of the major systems have been tested and are working. We're awaiting delivery of one last component. That's the vertical focusing mirror, which I understand just shipped today. So we should have it in the next few days and be ready to install it in the coming weeks. Not all experiments on this beamline require that mirror, and so we have in fact done several user experiments on the tomography program as well as the larger volume press program in the last few weeks, and we expect this beamline to return to general user operations also in the first cycle of 2025-1. So far on the 13 BM beamlines, we've hosted 7 external user groups. We've got 6 more scheduled in the next couple of weeks, and I think additional experiments are to come. So we're excited to have users back on the beamlines and doing experiments with us. And so I want to show you just a little bit of what's going on there. So these twirling colorful objects are tomographic reconstructions at the upper right of an olivine grain. This is an experiment done by Philip Ruprecht of the University of Nevada. At the bottom, those 2 twirling things are ancient marine animal fossils provided by the Geological Survey of Canada and being studied by Jar Harday and Patrick Lariviere from the University of Chicago. All of these data were collected in white beam. Pixel sizes are just a little over a micron for these particular data sets. And to give you a sense of scale, the horizontal fields of view in these images are on the order of 2 millimeters or so. One of the great things about collecting these data in white beam means that our collection times are just under a minute for each of these objects. So that's 13 BMD. At 13 BMC, we had our first user group, Wenli B's group from the University of Alabama, come to look at magnetic materials under high pressure. This experiment was also an excellent opportunity to test and commission a cadmium telluride area detector in this station where we hadn't used it before, and we're seeing very nice performance there. We'll move on now to the undulator beamlines. So on the CD branch of the 13 ID, we have a new monochromator with installation actually sort of completed, depending on how you count, in the last few hours. We just had beam on this monochromator for the first time about 30 minutes ago. And so we're looking forward to commissioning that. The large volume press program has already made some use of this beamline, though, because they can do some diffraction and imaging with white beam. And in fact, so they've made some measurements already in white beam. For the diamond anvil cell program, we have fabrication and assembly of a new experimental table, as well as new high precision focusing optics underway. Those will probably be installed in early 2025. We also have a new Eiger 9M detector on hand. Initial commissioning of this program will use the existing table, so we will do some diamond anvil cell commissioning in the next few weeks probably, but that new table will be installed a little bit later, probably in 2025. Early 2025. On the surface and interface program, we're in the midst of an upgrade of our diffractometer, and we also are expecting to take delivery of new focusing optics in 2025. Initial commissioning there will use the existing mirrors. And we expect this beamline to transition to scientific commissioning and first users either later in this run cycle in the next few weeks or maybe in early 2025-1. At 13 IDE, which is our microprobe station, our double horizontal mirrors have been repolished in order to leverage the characteristics of the new source, and they've been installed and tested. The monochromator is the same monochromator we've had for a number of years and is working well, although we plan to upgrade it soon for better thermal management, probably in the next few months. We've got new high precision focusing optics in hand for this station, but we're still waiting on some modifications to the bender mechanisms for that. So we expect to complete that installation in the next few months. And so we're doing initial commissioning there with the older existing KB mirrors. But I have to say, even with those older KB mirrors, we're able to see significant enhancement in spatial resolution afforded to us by APSU. So this image over on the right is a grid that's nickel coated onto silicon. And the feature sizes, which is to say the widths of the lines and the spaces between the lines, are given in microns by the numbers over at the right-hand side. And to give you a sense of sort of how far we've come with the old APS, we would have expected this image to go sort of blurry in the horizontal direction around 2 microns, in the vertical around 1.5. And you can see we're able to resolve these lines down under a micron here, again, with the old mirrors that have been sitting around in air for over a year, and with not a tremendous amount of effort. So this is really exciting news, that we're really going to benefit from this new source. All right, I'll transition now from the 13 beamlines to the other sectors. So SEAS supports half of a beamline scientist, as well as some equipment purchases at Sector 3, where the APS does nuclear resonance scattering experiments. Some of these experiments depend on the timing modes of the APS, and APSU has now tested 48 bunch mode, currents up to 100 milliamp. And what they see is an electron bunch purity that's significantly better than the bunch purity that was available prior to APSU. That means they're going to be able to narrow their veto window and have a lot of improvements for the studies that they do there. And they're excited to have SEAS users come and measure things like densities of states and sound velocities of materials at high pressure. They've also had their first user experiments. So this beamline is in scientific commissioning mode, and have already measured some nice data with users. And so they're excited to be welcoming users back at 3ID. SEAS also supports a multi-anvil press program at 6BM via a subaward to Stony Brook University, where the beamline scientist there is Haiyan Chen. This is a beamline with high pressure deformation apparatus. They can do energy dispersive diffraction, as well as radiography and acoustics measurements. These things taken together allow them to look at phase transitions, equations of state, mineral and rock deformations, and over a sort of range of millihertz to megahertz kind of time scales. At 6BM, they've upgraded a number of components related to the beamline control systems. They have completed shielding verification and done most of their technical commissioning at this point. This beamline is shared, so there's a 6BMA station and a 6BMB station. The large press is in 6BMB, but the APS has a program that they run in 6BMA, and so that program is finishing up some of their technical commissioning before this beamline transitions to scientific commissioning, but we're optimistic that that'll happen in the next couple of weeks. And they're ready to take rapid access proposals for the end of this cycle and expect a normal user run in 2025-1. So if you're interested in coming, and we hope you are, there's a new universal proposal system with a link shown here, and I think Emily's maybe going to put that in the chat. And all SEAS supported beamlines at the APS are accepting user proposals right now. The call for rapid access for the current run cycle, which ends in December, is open and available now. The general user proposal deadline for the first run of 2025 was October 25th, so that's passed. However, a rapid access call for that run cycle will open up probably sometime in January, and then the summer run will have a deadline in March. So we encourage you to put in proposals and come back and see us, but perhaps even more importantly, if in order to sort of understand the nuances and details of the techniques and beamlines that you're most interested in using, we really encourage you to contact the beamline scientists directly to find out what's possible now and what timelines are for when things will come back online. And I think that's all I've got.
Thanks very much, Joanne. If any of you have questions on anything Joanne just presented, please put those in the chat. In the chat, you'll also notice links to a number of the important points that she made. Next item on our agenda here is an update on the planned ALSU upgrade at the Advanced Light Source from Martin Kunz.
Yes, good afternoon. I'm going to share my slides as well. Okay, so yeah, my name is Martin Kunz. I'm a beamline scientist at ALS. I'm an ALS beamline scientist of one of the SEAS beamlines. And I should warn that I'm not actually a specialist in ALSU, but I should be able to give you a suitable update on where the project is and its impact on the beamlines. So I will quickly present the ALSU project, similar way that Joanne did. I give a update on the timeline and the current status of the project, and specifically also on the timeline for the individual Cs-related beamlines. And then I will show some slides on the impact of the ALSU on the various Cs beamlines. So the ALSU project is also aiming at moving the ALS to an ultimate storage ring, and it does that the same way as the APS upgrade did it, by reducing the horizontal beam size massively into a very small circular electron cross section. This is being done by replacing the current 3-band lattice with a 9-band multi-band achromat. And the net result of this is that the coherent flux of the ALS after the ALSU upgrade will be increased by several orders of magnitudes in the soft to low tender energy X-ray energy range. This is being done in detail, also very similar, I think, as it has been done at the APS. The main feature of it is that they will do a full energy swap out and bunch strain recovery. That means the top off will not be done on the electron beam in the storage ring, but it will be actually done in a separate accumulator ring. And then the individual bunch strains are kind of swapped out on the fly. So this is needed because the fluctuations during the top off regulations for this small beam is too much to actually maintain a stable beam in the storage ring. In practice, that means that besides exchanging the storage ring, the entire storage ring, there has to be a completely new accumulator ring installed, and this is being done at the ALS in that it's basically attached to the inner shield wall of the storage ring tunnel. The nice thing is that boostering and LINAC and all that stays the same. In addition to all this accelerator work, there has to be actually done a seismic upgrade of the shielding, and that has, of course, to do with the fact that the ALS it's like a stone throw away from the Hayward fault. So let me say something on the timeline. This represents the currently official timeline. The timeline of the upgrade also centers around the 1 year long dark time where all the beamlines will be shut down. That's the time when the storage ring will be replaced. The dark time for the individual beamlines is different for different beamlines. Some of the beamlines will have to be shut down in advance of the start of the dark time. That's mainly for logistical reasons. And as those of you who happen to have been users at the ALS already know, is that the dark time is kind of preceded by a lengthy, what we call a dusk time, in that our actual active cycles are much, much longer on the expense of very long shutdowns twice a year. And the reason for this is that a lot of the installations, as much as possible, is being done ahead of the dark time, so that the dark time actually can be focused on the storage ring. There is a little caveat to this schedule as it is shown here, in that we have recently been communicated there is a good chance that the schedule has to be modified, in that the dark time will be delayed by some amount of time. We so far don't really know how much that is. There's various ranges floating around. The ALSU project is currently under a external review to properly assess the exact length of this needed delay. And the ALS, it's also not fully clear yet in what way this would affect the cycle length of the additional cycles, whether the shutdowns will continue in the that long as they are now, or whether maybe within a year then we can go back to shorter shutdowns, longer cycles, until then the dark time will start at the at not yet known time. The current status of the shutdown is as follows. The project in the past about a year and a half has proceeded to install the accumulator ring on the inner side of the storage ring wall. And you can see this on this picture here. There's one of the specific problems of the ALS upgrade is that the ALS ring is very small. It's only 200 meters of circumference compared to about 1 kilometer at the APS, which leads to extreme tight spaces. And I think that was also part of the reason for some technical problems, which contributed to this possible delay of the shutdown of the dark time. Currently, the accumulator ring has been installed to about 75%. And in addition to the accumulator ring, the accumulator ring radio frequency cavities have been installed too, as been seen on these pictures. This also happened last summer. And this again is a testament to the tight space constraints that we are dealing with here, not only to actually position these components in the ring, but also to actually physically place them in there without bumping into all also existing components. As to the beamline timeline, specifically the Cs, obviously the absolute timeline hinges on the LSU timeline, which, as I said, is kind of a little bit unknown right now. But the relative timelines is as follows, and I think this is, for me, some of this is relatively new and kind of encouraging. So 832, which is the tomography beamline, will be moved during the dark time. I should actually say all the beamlines that have to be moved will be moved during the dark time. For a long time, that was not clear whether the move will happen actually even after the dark time, leading to much longer beamline downtimes. But all of the beamlines will be moved during the dark time by various amounts. And the good thing about this is that the beamline should be operational after the end of the accelerator is commissioned, and we can then actually immediately start with the beamline recommissioning. The beamlines 532 and Cosmic Q, which are part of the sister subaward, they do not need to be moved, or they are actually newly built. So Cosmic Q, for example, is one of the ALSU flagship that's going to replace 1102 and 701. And that's completely newly built. Hence, that's actually a large priority of the ALSU projects. It will hopefully also be completed by the end of the dark time. 532 does not need to be moved. It needs new optics with new deflection angles. Let me say some words on the ALSU impact on the various Cs beamlines. 532 is a soft X-ray scanning transmission X-ray microscopy beamline. Its benefits from support of the sister subaward. So this beamline, which operates between about 200 and 700 plus electron volt, will gain in flux by about 30%. You see in this figure on the right, the relative flux change from ALS to ALSU. So at lower energies, it will gain about 30%, but this is further enhanced by the fact that the source is so small, and therefore we gain in brightness. So the amount of photons on the sample will be about 5-fold. This will allow for faster scans. We'll, of course, also need new X-ray mirrors to enact this gain. And faster scans would be definitely interesting for the environmental science community, which often relies on very large, high-resolution, multidimensional scans for complex heterogeneous samples. Then the other sister supported beamline will be Cosmic Q, which, as I mentioned, replaces 11022 and 7012. And this one is actually the one beamline relevant to sister, which really will benefit from the LSU upgrade. So this graph, Cosmic, is the blue curve, and it will actually gain relative to ALS by about a factor of 100 in brightness. And this on top of a 2- to 3-fold increase in spatial resolution. This results in about 100 times faster scanning times. And it should be said that in order to really exploit these faster scanning times, appropriate detectors have to be developed. And because unlike for hard X-rays, where there's a large amount of commercially available very fast detectors around, this does not really exist for soft X-rays. And the ALS, together with other groups, is actually active in developing such a new soft X-ray fast detectors. The technique that's been applied here and will be benefit from ALSU will benefit from the high coherence of the new storage ring, which allows for this very fast tychography beamline, which is kind of a scanning transmission X-ray microscopy that employs the coherent scattering of a signal non-necessarily crystalline sample. And the combination of the two-dimensional scanning together with the two-dimensional information from the scattering image leads to about a 5 times higher spatial resolution. Then a beamline that will be part of the current Santa Cruz subaward is beamline 832. This is a hard X-ray tomography beamline. And this beamline is flux limited. And as you can see on these flux curves on the right side, the ALSU will employ softer high band magnets compared to the current ALS superbands. And for flux limited experiments, this will result in a decrease in flux. The experiments at 832 currently are mostly done between 30 and 40 kV or white light, which goes up to 60 kV. This is mostly relevant to the Earth and environmental science experiments. And they will somehow suffer from this upgrade that has to be said without trying to whitewash it. The smaller emittance kind of enhances the phase contrast, which would allow better phase contrast experiments. However, a lot of the Earth and environmental science experiments are not actually benefiting from this. The beamline, however, will be moved by about 7 inches, and this also will be moved during dark time. Then beamline 1222, that's the longest standing beamline that benefits from SEAS and compressed before, since about 20 years. It employs 2 staff members since many years, and it's specialized on experiments at non-ambient condition, and specifically at high pressure experiments in diamond anvil cells. And these experiments are brightness limited. And in terms of brightness, despite the fact that we also would lose a significant amount of flux, we can actually compensate by implementing new optics. We could compensate with a smaller source size for the loss of flux that we break about even in terms of photons on the sample, up to about 30 kV. This does require, though, new optics on a new mirror on M2 and new KVs, and it will also require some rearrangement in the hutch on the experimental table, since the smaller source allows for a smaller KV demagnification. Hence, we have to move the primary source by about 1 meter. The beamline again will be moved during dark time and should be ready for commissioning as soon as the dark time is over. And then finally, I want to say some words on beamline 1232. 1232 is actually not supported by SEAS currently. Also, it's listed on the SEAS website as one of the SEAS beamlines, but it certainly has a very strong Earth and environmental science program going on. It's specialized on doing Lowy microrefraction with a pink beam between 6 and about 33 kV. And this is actually one of the few hard X-ray beamlines which will truly benefit from the ALSU upgrade, since it's heavily brightness limited, and the geometry of the beamline is such that the flux passing through the secondary source in the hutch will increase by about 255% after ALSU. And the beamline again will be moved by similar amount again during dark time, and hopefully will be ready for commissioning once the accelerators finally commissioned. And this is all I have to say for now.
Yeah, thanks very much, Martin. Yes, as Martin said, if you have questions, please put them in the chat or hold them for our Q&A session at the end. Our next presentation will be offered by Matt Newville of University of Chicago, discussing FAIR data policy and practices for SEAS.
Okay, thanks, and everyone for coming. I hope you can see my screen and hear me okay. I'm going to talk to you about the data management plan for SEAS, which as written for the proposal, states that we will work towards making all data collected with SEAS-supported facilities publicly available and complying with the FAIR data principles of making data findable, accessible, interoperable, and reusable. And we also say that we will engage with the SEAS user community to establish policies and procedures. So thanks for being here. We need your help. This is part of our management plan to have meetings like this. So just to be clear, what we mean by FAIR data principles say that federally funded research data should be made publicly available after some embargo period, so available to the general public. And the data should be in usable formats and with consistent metadata and not just be a pile of junk, but be actually usable. So at many universities or for other specific fields, there are many existing repositories, but as far as we know, these do not support large data sets that are common with synchrotron beamlines, which easily generate data sets in the 5 to 500 gigabyte range just in a few hours even. Now, we know that several European synchrotrons or end user facilities, so the neutron and muon sources as well, are making data publicly available or are working to do so within the next few years. On the other hand, the DOE-funded synchrotron and user facilities are not doing this themselves, at least not yet, and maybe that will change, but we can't rely on that happening yet. So SEAS is planning to manage an online catalog of data collected at SEAS beamlines, including the SEAS-funded work at the beamlines that it uses part-time. That is, data collected by SEAS will be made public. So what's this going to look like? Well, we have a plan, or maybe a concept of a plan. We'll set up a data catalog using what's called the SciCat project, which is out of the Paul Scherrer Institute with the Swiss light source and their neutron source there. And it's used by many European facilities, or being implemented by many European facilities. For us, it has the advantage that it already knows about like a beam run and a beam time with a user group. So it's better than many of the catalogs that are used by university libraries, for example. So data will be organized in this catalog by experiment ID, which is like the information that's on the safety form, and with metadata that will include things like the proposal title and maybe the abstract, the beamline name and information about the beamline, and the usernames and maybe their ORCID IDs if we can get all of that, and then the list of samples that's on the ESAP. Getting sample information that's reliable and useful into this kind of system will rely on the users providing that to us, but we can provide whatever we have. So all the data from an experiment run will be given we'll give it a unique digital object identifier, or DOI, so that it can be referenced with a single URL and looked up. We'll catalog it and we'll make it available in stages. So first, it'll only be available to the experimenters who collected the data and to the beamline staff at that beamline, and then eventually be made public. There are examples of SciCat and other similar data stores. So for example, the data store at ESRF, the link is there. Actually, that does not use SciCat. That uses their own home-built system that they tell us to not bother using. But then the data on this image is from Max4 and their SciCat implementation. So we're in the early stages of doing this, and there's several things to work out. Like, we don't yet have SciCat catalog running on our servers. We think we can do that, but we don't have it running yet. We need to make the FAIR data policies clear to all of our users before they start taking data. We'll also need to work on automating the transfer of data from the C-supported beamlines, especially those that aren't at the APS, to the storage that we have at the APS. We will need to automatically generate these digital object identifiers for metadata. We have some of that in hand, but we need to make that more robust. And then we need to automate either permanent or on-demand links and downloads for data using just plain web pages or things like Globus or Nextcloud to transfer larger data sizes. So as we're thinking about this, we expect the SEAS beamlines as a whole over all of the SEAS beamlines will support about 1,000 individual experiments per year. So these steps for turning the experiment IDs into catalogs that are on web pages and easily findable needs to be robust and automated. So we need to work on that. I'll also say currently what we have on hand is about 600 terabytes of storage available for this new data. We have an 800 something terabyte system and it has 200 terabytes on it already. So we have 600 left. And we may be able to use some of the Argonne or our own tape archiving services to automate archiving and retrieving of older data from tape, so that if someone comes and wants to look up data that's 5 years old, they may have to wait a day while it's retrieved from tape. But we're hoping that much of the more recent data can be kept at least partly spinning on places where you can just download it. So to help us out with this, the SEAS user group with chairs Mary Jo Brown and Bin Chen sent out a survey on FAIR data policies to the SEAS users. And there were 36 responses, so about the same number of people who are here. And they were mostly positive. That the report from that is available at this link I give down below. And most of the responses were positive, and they understood and outlined the challenges of doing this kind of effort. And they also saw that working towards more uniform data formats is important, but also real effort to try to get the data that's collected in even the same type of data, diffraction at high pressure, into the same format from all the beamlines is challenging. We want to make those efforts, but it's not going to stop us from sharing data that we have. Metadata about the sample in particular and sample conditions is very hard to think about how to automate, and something that's sort of out of our hands, but we would love it if this community of synchrotron Earth environmental sciences could come to some agreement or standard practices on that. There were also in the survey, there's some real concerns about data theft and security of data that's being collected. So we'd like to also make sure that we are paying attention to that. And then the final result was the community wants what seems like a relatively long embargo period, which I'll show here. For embargo period, the survey results had most respondents in favor of a combined 5 years or publication, whichever comes first approach for an embargo time between when you take data and when it's made publicly available. So there's a strong desire to protect training processes for graduate students and postdocs and so on. And that especially for beam time that's hard to get, it can be a slow process to get beam time. So I'll say a couple of things about this. First is that time of publication is challenging. We have a hard time tracking publications as it is. So for us to know which data sets went with a publication, at least if we started from 3 or 4 years ago, that would be challenging for us. So again, assigning data set digital object identifiers at the start of each beamline, beam time for each experiment would be highly useful for us, that we could provide that to the user, say, here's where the link for this data set is going to be, and will you please include that in the publication about the data. Then we would be able to track whether a publication used a data set or not. Otherwise, it's difficult for us to be able to police that. In addition, although the SEAS award started a year ago, just before the SEAS award started, NSF published revised guidelines for its data management plans for new proposals that are submitted presumably anytime after July of 2023. And these require FAIR data principles and give a lot more details than is in our actual data management plan. So some quotes from that I think are useful to discuss here. One is that all new data resulting from the project of a new proposal must be made publicly accessible within 2 years after completion of data collection and generation via appropriate long-lived FAIR-aligned repositories. And data available upon request is not acceptable. Data that's put into a publication should be made available immediately at the time of publication. And they also define data, just to be clear, they define data as including all observational, experimental, analytic, and models, including software and code, educational materials, and other relevant digital products from a project. So the beamline data that we collect is definitely data that they intend to have fits under this FAIR data policy guidelines. And then finally, I'll say that for proposals providing community survey infrastructure or research services, that's the SEAS beamlines. The data management plan should describe the data sample types to be managed and what guidance or support will be provided to help users meet their sharing obligations. So that's saying that we as SEAS ought to have a plan for helping you all, NSF-funded scientists, be able to share your data according to the plans, according to these data management plans that you will need to provide to NSF for your grants funding the work you do at SEAS. Okay, so it's not clear. It's not clear that the SEAS data management plan needs to be revised to match these exactly, but it outlines what the expectations are and what would have to be put into the next upgrade or renewal for the SEAS proposal. So we need your help defining the embargo period. There's sort of 3 different answers: 2 years, which is what NSF-A.I.R says, ESRF, and what we had originally said our intent was to follow the ESRF model of having 3 years, or the 5 years from the user survey. And I want to say, like, you know, we're the beamline scientists, and we understand, and we take data, we see this too. We understand the cadence of beam time proposals. 1 or 2 runs a year for a study means that experiments often take at least 2 years to complete, sometimes more. But we also want to be clear that we need to organize data by beam time or experiment, not just by what a user's definition of a completed project is, because we don't know how long a student's project takes if it spans multiple beam times or even beam times at different facilities. That's just too hard for us to track. So I think one route that we might be able to take is that we could interpret this 2 years after completion of data collection or generation as being 2 years after the completion of the allocated beam time proposal, right? So all of the facilities have some way of giving a beam time proposal time for approximately 2 years. It varies by facility, but approximately 2 years. And so we might be able to say that once a beam time proposal is done, then the data from that beam time proposal is embargoed for 2 years at the end of the proposal. So some of the data, the first data collected, might be embargoed for up to, say, 4 years, while the last data from a beam time would be embargoed just for those last 2 years. But when the beam time proposal ends, then the 2-year clock starts. So again, this varies by facility, but most of the facilities have this sort of time scale and duration of awards for beam time proposals. So there's a few other questions that we have that are like for us. About the embargo time? Do we need to increase the embargo time for students' theses? Is that an extra year? And how do we manage or enforce that? How important is it that we give students extra time? But there are a bunch of other questions that we have, especially I think the beamline scientists and people running the facilities here, like, what if your grants have conflicting requirements for data sharing? They might be more strict, they might be forbid some examples, or some sharing of data. For example, if you have export or controls or security concerns on data that you collect. And I think there's a fair question that if we need to give beam time to general users at the APS or ALS or NSLS2 or SSRL on our beamlines, do those general users who aren't earth scientists, say people coming to do battery research, do we expect them to follow these policies as well? And if the DOE, especially given that the DOE facilities don't quite yet have FAIR data policies that are explicitly or that are very explicit yet. I think these are open questions that we don't know the answer to, but maybe you can help us out with. And there's also a question of which experiments a beam beamlines that are only partly SEAS funded are archived. There may be some. I think it might be fair to say that if a SEAS funded scientist helps you collect the data, then that counts. But there might be some subtle cases that aren't so obvious, and I think we need to be mindful of how to be fair about that, but also be clear that we want the data that's SEAS funded being made available. I think there's also a question of whether we can also start cataloging the experiment data and then move it to a centralized repository separately, and that like the storage of the data versus the cataloging, can that be done separately? I think we can do that, but just want to be clear that like that's something we're considering too. So for example, if there's tomography data from ALS, can we just catalog the metadata but not have to move the data, all of the data over here to our APS hosted servers. We also need help with, so I'll just like add this, we also need help with data formats and metadata. I've had lots of discussions about data formats and Nexus formats for spectroscopy data over the last couple of years. And we need to, as we're making data available, it doesn't do much good if they're a mess or hard to decipher. And the goal is, actually, so it's like obfuscating the data or making it hard to use is not the goal. The goal is to make it easy to use and to make it readily available. So working on data formats would be a very good thing for you all to help us out with. So if you're working on standards for your data or subfields or across the SEAS beamlines, it would be very helpful for everyone if you could help us get to a point where our data can be in stable formats. The NSF guidelines also, if you go find them and read them, they also apply to data and samples, which they go through in great length of how to catalog samples, and that will likely be coming your way too if you're NSF funded or going to be. And so working on that would help everyone out. I think we just have no idea how to really be able to catalog the samples that you bring to the beamline. We need your help with that. There's also, before I end, I'll answer a few questions that came in the registration form. There's a questionnaire on the registration form, and there were a few questions put in. So one was, is this new proposed data sharing policy a result of DOE or NSF directive? And yes, this is NSF influenced. And then there was, are there plans or examples of open source analysis scripts being made available at beamlines for processing beamline specific data on the fly to make beamlines more efficient? And I would say, yes, many beamlines have such scripts, and improving this is a great thing to work on. So if you're asking this question, maybe you're working at a beamline that needs help with that, and maybe you could reach out to us and let us know, and we'd be happy to talk to you about that. And then finally, there's a question about XAFs. So I'll say that, like, is there interest in the part of the FAIR data sharing to create a database for common minerals that are used as standards in XAFs? And I'll say, yes, we're interested in that. Why don't you contact me, and we'd probably just need good mineral samples. But I think that would be a great thing for everyone in the community, and work has been going on in that as well. So we need your help. The policies for data sharing, including embargo time, are going to be set pretty soon. So we would like your input on this. We expect that we'll be able to assign dataset DOIs at the start of each beam time, hopefully to be used in publications. And we'll be able to catalog metadata about each experiment that's supported by SEAS, and eventually make the data available public too. And we're going to propose or have a discussion with NSF and see if this interpretation of 2 years after the completion of data collection with a beam time proposal is a fair way to start the clock for sharing data. Again, we'll have to hear from you. So if you have questions or comments now, let us know. But if you want to have a one-on-one conversation, let us know. And finally, I'll say as a final, this town hall this topic came up as a good thing to have for a town hall. So if you have suggestions for what else could be a SEAS town hall, please let us know. And with that, I'll ask one more like sort of bonus, is that we can now do some data hosting services for you. We can now create SEAS branded DOIs for data sets that we host on our server. So this idea that as you're publishing work for a paper and you want to make data sets available in that publication, say as supplemental information, if you want to create a DOI for that and you don't have that ability, or I think there are services that can do that like Zenodo and Figshare, but we can do that too. And if you would like to do that, let us know. We don't have this automated yet, but it's on our to-do list, and we would like to be able to do this for more people, at least for the data we make. So with that, I'll ask for any questions or comments.